This episode of the Ask the Masters podcast is being brought to you by Pentair. Welcome to the 30th episode of the Ask the Masters podcast. On this episode, Master Paolo Benedetti and Master Rick Chafey discuss architecturally integrated water elements and complex swimming pool construction. Enjoy this very informative episode. Hello and welcome to the Ask the Masters podcast. This podcast is dedicated to discussions about the design and construction of water shapes. The hosts of the show are all certified SWD masters who represent the leading builders and designers within the water shaping industry today.
Good morning. Welcome to Ask the Masters. I am Rick Chafey with Red Rock Contractors, and I'm here with Paolo Benedetti with Aquatic Technology. Good morning, Paolo.
Good morning, Rick.
What are we going to talk about today?
I think we're going to talk about architecturally integrated structures.
And water features in general, right?
And water features in general that are integrated with the architecture and the various issues that people have experienced over the years and how to plan and prevent those problems.
So both of us have done projects over the years, and many of the Genesis guys, that's kind of some of our specialty, I think, is how we're able to integrate a water feature, both just stylistically into the architecture, but also actually physically integrated into the architecture. And is that what we're talking about today?
That's what we're going to talk about today is some of those construction obstacles, not only during the execution, but things you need to think about during the planning phases.
What do you see as the most critical piece of that architecturally integrated piece? What's the most critical thing you need to worry about?
Waterproofing. And I use this analogy a lot when I'm in design meetings. I say the W is not only for waterproofing, but there's three phases of the waterproofing. So we've got the integral waterproofing in our concrete. We've got some type of membrane system on the inside, and then we have some type of mechanical system for the penetrations.
Okay. And then we also need to worry about the migration of water, right? So regardless of whether we waterproof something and keep it from getting into the structure, it tends to want to migrate around and through and over quite a bit.
Yeah, what we find is that water will tend to want to find our conduits and our pipes that are exterior to the structure from other sources, whether it's from drainage pipes, condensation, irrigation, and will tend to want to follow the perimeter of those pipes along their course. And so the water might not even be related to the pool, but they're coming from external sources, and they're being drawn into the structure from these devices and pipes that leave our structure.
Yeah, we've found that to be true as well. And on a specific project, we exactly had that problem. We had gas lines that were sleeved into our same area to work, and we ended up having water that was coming off a roof deck getting into the gas line sleeving and showing up as if we had a pool leak. Luckily, it only happened when it rained, so we could easily prove that it was not a continuous pool issue. But I think critical to the process of the construction side of that is to be very acute, to pay attention to what else is around you, what other physical things are around you, irrigation-wise, water-wise, to make sure that you can separate those two, or at least know what you might be running into, and help others on the project know that they've got to stay and waterproof around or keep it out of your structure. But what's the easiest way to try to prove when you do find water that it's not maybe, or that it is maybe coming from the structure of the feature?
I'm glad you just touched on that, because there was recently an issue that was posted on Ask the Masters on Facebook about trying to determine whether it was irrigation water, a pool leak, or condensation. And one of the few things that is unique to swimming pool water is the presence of cyanuric acid,
okay,
and that it will migrate through concrete. So if in fact you can raise the cyanuric levels in the vessel and then test the water, the leak water, for the presence of cyanuric acid, that'll tell you whether it actually is leak water coming through or whether it's from some external source, whether it's condensation or irrigation or a leaky rooftop drain.
That's a cool little trick. You wouldn't think that you'd be able to do that, because obviously some tap water will have chlorine in it, and a lot of other minerals are tough, and the chlorine level will be so low it'd be tough to even acknowledge, probably.
Exactly.
Whether it came from the pool or the tap water source.
And I learned this trick kind of actually on one of the expert witness cases I was doing. The pool was leaking. Landscape contractors were digging a hole nearby the pool for putting a tree, and every time they dig the hole, it would just fill full of water. They'd pump it out, it would fill. The landscape contractors were telling the pool contractor he had a leak. They were arguing with each other, and they tested the water, and they said, well, it's got a little chlorine in it. The tap water does too. And I said, well, what else is in pool water? And I thought, well, if it's leaking, it's going to be cyanuric. So they tested it, and there was about 20 parts per million of cyanuric, and the pool contractor said, you got a leak.
Yep. What's funny is I think the important thing too when we get to the soil areas like a tree, depending on the soil types, you can end up with very transient water. And so you can have a water source that can be hundreds of yards away, and especially on hillsides and slopes, but even on flat grades, if you've got clay layers and different layers of soil, you can have water that is migrating drastically farther than you would ever expect it to, and have it be the same source. And that would be a way to prove as well. You could be 30 yards away from a body of water that you built and find out you got cyanuric acid, and it absolutely could be coming from your shell. So
right.
It's definitely an issue.
It's kind of the only way that you can really put a tag in the water, like a radioactive isotope that you can actually track.
Right.
There's no other real chemical you can put in the water that you can track and actually go back to the source. But you kind of mentioned something about water migration, and that's probably one of the hardest things in our industry to troubleshoot, is the source of a leak, whether it's a vanishing edge wall, whether it's a leak exterior to the structure. If water is migrating through the structure, it'll follow a pipe, it'll follow a fissure, it'll follow the honeycomb or the trowel marks behind tile for a very long distance till it finally hits a blockade, where then it has to come to the surface. And that'll either manifest itself as efflorescence or just a visual leak or dampness. And sometimes it's coming out not always in the best places.
Right. Well, I think that leads to like you brought up. I think I always say there's three critical things about architecturally integrated structures, and it's actually waterproofing on all three. There's layers of waterproofing, but because it's so hard to find a minor leak like that, you have to make sure that you don't end up with a minor leak. Mostly because you could spend, if you've got we did a rooftop pool with all glass tile. If we end up with a small leak in there, man, we could be just destructing the entire pool by the time we actually find the leak, and you can go back and forth so many times. And so that's why, as you brought up, there's multiple layers to the waterproofing system, so that we protect ourselves from having any chance of a leak, because every one of those could have a minor issue. But if we layer waterproofing systems, not just two different layers of elastomeric or something, but if we layer the process through the entire construction, integral waterproofing systems, surface waterproofing systems, any manner, and then if we can get a primary waterproofing layer that we put in before we even construct the vessel, those will all start to take effect, so that we can have a little bit of, take away some of the risk of the fact that we might have a leak, and then we're not chasing something that's extremely difficult to locate.
The compatibility of those various systems is probably, I think, the biggest bane of a designer or a contractor, is trying to find integral waterproofers that are compatible with membrane systems that are compatible. I mean, mechanical systems aren't so much of a big deal because it's a mechanical component.
Right.
But trying to find systems that are compatible with each other. I have a project we're doing now where we've got integral waterproofing in a cast shell. The profile is very smooth because they use steel forms, and then we tried to put a cementitious waterproofer on it that stuck in some areas and didn't in others. And then we were kind of backtracking, trying to figure out why it was peeling, and we ascertained through spectrographic analysis that somebody had put a colloidal silicate sealer on top of that concrete. So it made the surface so bloody dense that we couldn't even get a mechanical bond.
Right.
So we had to go back and literally grind it,
reprofile it,
and get a good bite, so the cementitious waterproofer would bond.
Well, I think that the systems approach is what's important, and there's now, luckily, there's a number of different manufacturers that have started to kind of give us a soup to nuts product too. So we have all the pieces that we know are compatible, because it's very tough to get three different manufacturers to agree that we can put their product on top of somebody else's that has something inside of it. So as a contractor and as a specifier, it's important to try to find a systems approach from whatever manufacturer you're working with, and also make sure you're following the requirements, because they're all slightly different. Multiple different companies have cementitious waterproofing. Multiple other contractors have colloidal silicate, but they don't always have a system you can work with. So it's really important now, if you can, to work through some manufacturer's entire system and then follow that product. And so the ones that have a full system also have methods for pipe penetrations and details for that stuff. And most people don't realize that there is good specific details on how you can waterproof around penetrations and how you can deal with corners and intersections and different profiles. So when you get into that type of project, it's really important to pay a lot of attention to that. And oftentimes you can just hire a waterproofing consultant. Either the manufacturer will provide you one, or you can hire consultants that's all they do. And they'll be specific to it. They'll warranty it for you, because we've got a commercial waterproofing project we're working on right now, and it requires a 10-year warranty. Well, if we just went with some simple surface waterproofing system that seems to be working for us, we probably wouldn't be able to maintain a 10-year warranty. And if we didn't work around the pipes and everything correctly, we certainly wouldn't be able to give them that kind of warranty. So we've hired a consulting firm and a manufacturer to work with together to actually install that system.
So you've kind of touched on one of the very first key elements of putting together an integrated structure is the planning phase. So it's not only before you start construction, it's starting to determine what are the processes we're going to use and what products are we going to use, but actually determining and detailing the corners, the inside corners, the outside corners, the drains, the pitches, the mechanical systems, how all these systems are going to interface with each other, and then getting the manufacturers on the same page.
Right.
I find that the disconnect is between the integral waterproofing manufacturers and then the surface waterproofers. And that's where we still kind of have a disconnect because those manufacturers haven't really got together yet. And
right. Yeah, and you definitely can work and find the ones that do work, and you need to be planned well ahead. And especially, we talked about this earlier in a different podcast, and the fact that, I think you said it, as the closer the pool gets to the actual architecture, the more important elevations, dimensions, everything starts to get much more important. When we're 30 feet from a house, if we're an inch or two high, or the pool's a couple inches bigger than the plan really shows, nobody picks up on that. When we start bringing that structure either underneath the architecture or attached to the architecture, now our elevations are critical. We can't, we're an inch too high. Well, now we've ruined the drainage plan for the entire back patio or the rooftop deck or whatever we're working on. So pre-planning and working together with the architectural firm that's involved is critical. And we talked about this earlier too, is I think the best time to bring the pool designer in when you've got a proper pool designer is before the project maybe is even on the board, so that you know what you have for a resource and then you know when you can engage them. I think most architects are afraid to engage or don't know who they could engage at all, and so it also often gets left to the very end of a project where it might even be under construction, and now they've engaged a pool builder, but they still haven't actually engaged a pool designer, and that'll, especially architecturally integrated projects, that'll really hinder the end result often if they haven't brought that person in soon enough.
Here's a quick word from Pentair.
So talk a little bit about the Intellicenter, and we're coming off of IntelliTouch. That was kind of the big granddaddy
Sure.
that you guys had. But now with the Intellicenter, we're not having to buy all of these extra boxes and everything. Everything is based right on the board right there. We can control 8, 16 variable speed pumps. It's the capability expansion with this new Intellicenter is light years.
So a couple of the biggest advantages is, you touched on it earlier, is a touch screen at the equipment pad. For years and years, if it was an IntelliTouch system, you had to have what we call a serviceman panel. If the house was locked and you couldn't get into the homeowner's touch panel inside their house, you couldn't change any programming if you didn't have the screen logic. You couldn't change speeds on the pump. You couldn't do anything from the pad. So the Intellicenter allows you to do that. The Intellicenter also gives you the ability, if you sell a job today on a new construction application and the homeowner only needs 4 auxiliaries, and maybe they initially decide they just want a single body, they want a pool or they want a spa, and you go by the electrical panel or the box and you hang it on the wall, and as the job progresses, the homeowner decides, I want to turn on the barbecue lights, I want to turn on an extra fountain that I'm going to put in the backyard. You were limited to the number of auxiliaries that were in this box. The Intellicenter has what we call edge technology, that it gives you the ability to open up the panel and slide another PC card on the end of the brains of the Intellicenter that expands it from a 4 auxiliary to 8 auxiliaries by sliding this card on there. So you don't have to take a whole panel off the wall, replace the guts. That's a pretty huge benefit. Another benefit is every Intellicenter has the software built into it to control it from an app. In the past, you would buy an IntelliTouch system or an EasyTouch system, and then if the consumer wanted it or if the builder wanted to put it in for ease of maintenance or service, they would add a screen logic to that. The Intellicenter app is built into the Intellicenter platform, so it comes built into the system. So it has the ability to add on, where in the past we haven't had that ability without changing the heart of the system or a PC board or a motherboard.
Tom and I were out on a job a number of years ago before the Intellicenter was out yet.
Yep.
And we had a pool spa combo and then another spa and another another body of water. And so we had multiple heaters, and really we were a bit hamstrung, and we had to get creative with how I did that.
Yeah.
But that capability now with the Intellicenter, it just opens all of that up.
So if you look at the automation that we make an easy touch platform that'll do 2 variable speed pumps. And then we go to the IntelliTouch that has had the ability to do 8 variable speed pumps, or a combination of. The Intellicenter platform gives you the ability to do 16 variable speed pumps. And on jobs like that, sometimes in the past we've made decisions that aren't the best decision for the consumer, but we've had to put single speed pumps in maybe where we didn't want to on a water feature, to have the ability to dial it in exactly how the consumer wants it or what the feature needs for the water demand, because we were limited on how many variable speed pumps we could put on there. We think we've overcome that now with having the ability to do 16 and
multiple heaters.
And multiple heaters, absolutely.
Yeah, that was always, you had the I-10D that could have multiple heaters, but that was 2 single bodies. You couldn't have a combo and so that's what I'm really excited about.
Yeah, you had to do creative programming.
Yes. Yeah. So what do you see as the future of Intellicenter, and where you guys, where will this technology be in 5 years? Can you talk about it?
Well, so it's a little bit of a loaded question. I mean, as a manufacturer, we think we know what the future is going to hold, but none of us have a crystal ball. And that's the beautiful thing about the software on the Intellicenter and the processor, the microprocessors on there, is that we don't know what the industry wants. We don't know what the consumer wants. And the consumers inevitably are going to dictate what the future is. With the Intellicenter, because we could update it just like an app, if in 3 months from now there's new technology for pool pumps or for pool heaters, there's parts of the country where they're talking about not being able to have gas heaters anymore. What does that mean for heat pumps? What does that mean for electric heaters? All electric heaters, and we don't know what that is today. So the future could be all of that. So as a manufacturer, do we focus all of our energy on all of that, or do we kind of, with the Intellicenter now, we don't have to. We could narrow that in, because we could turn on a dime now, where before we didn't have the ability to do that. Correct.
That's really, really cool. So this is going to be the platform that everybody needs to move towards in the future.
Sure. We don't want, as a manufacturer, to dictate to the industry what they need to put in. We want to have kind of a good, better, best today. And that comfort level is different for everybody in our industry. And that's our job, is to make sure that we're accessible to help them embrace the technology if they want to embrace it, but still have a product that works for them if they're not ready to kind of take that next step.
The other benefit of bringing in a designer or somebody early on in the design process is that we bring a lot of knowledge and past experience from other projects to the table, where we can help them oftentimes minimize their construction costs, because we can streamline their process. But sometimes we can also diminish the size of the structures. Sometimes we're finding that they're over designing the structures for the pool or their secondary containment. They're really going overboard because they're so concerned about the pool leaking, that we can actually help them develop these processes to kind of streamline their pool and minimize the weight and size of their structures.
Yeah, we've found often too that architects are usually afraid to use our structure for their foundation, and the end result is we end up with these big bulky foundations that we're then trying to work a water feature or a swimming pool around, when the reality is because of the geometry of what we're building, we're an excellent foundation system, because we're a huge spread foundation typically, or we're going to set it even on piers depending on the project. So you can really tighten up all the tolerances of what a project looks like. You want to get the inside outdoors all tied together, and you want the architecture to look as though it's sitting on top of the water. Well, there's no reason we can't actually sit it on top of the water. And sometimes that makes it both visually better, but also allows us to plan ahead and miss some of the problems. And like you said, the experience out there, a lot of times that experience is because of bad experience, right? We've tried it, didn't work, or we found an issue with it, but we found a way around it. And a lot of it comes down to flashing details and items like that, where we don't necessarily stop our structure where you think you would. Maybe we run the structure higher, and then we bring architecture back down, and we can eliminate a lot of those issues and help the architects through that process.
So let's talk a little bit about maybe some of the different waterproofing systems that we use, from the integral waterproofers to some of the surface systems that are used out there, and maybe discuss briefly some, not brand specific, but just some of the mechanical systems also.
So internal waterproofing, there's a number of different manufacturers that make a lot of different types of that. They're all fairly similar. Some of them, you have to be careful because some of them also will reduce the curing times and the setup times on concrete. So you definitely want to make sure that whether you're casting or shooting, that the crew is fairly well versed with the
Some
product.
will extend the setting times
or
too.
extend it, yeah.
I've had crews standing around for days waiting for stuff to set up so they can finish.
And it's going to come through the hose different. It's going to hit the wall differently. So there's a little bit. It adds a different dimension to the construction piece of it for sure. And it's considerably expensive. I mean, you can spend $50 to $100 a yard for integral waterproofing. Now, I first got introduced to that when we were doing a long linear water feature that was going to be left as cast. We actually cast the concrete but had no finishes going on, so we weren't going to have the ability to put a membrane or a tile finish or anything or repair cracks that we would find. And so we did quite a bit of research to find some of the best integral waterproofing systems, and I didn't have a ton of faith in them. I made sure that the owner knew that at some point we might have to come in and put a finish on the inside of the feature because it was so long and linear, it's bound to crack. It was all concrete, and so surely it did. Just where we thought it would, there was some steps in the wall, and it cracked right on those steps. And initially, we had water leakage. We had seepage and damp on the outside. Reached out to the manufacturer. They said, "You know what? We'll stand behind it either way. How big's the crack?" And it was visually bigger than I was hoping.
It was a shrinkage crack.
It was a shrinkage crack, and nothing, nothing structural, but it was big enough. You could get a business card in it on the outside, and so there wasn't much moisture coming through. But he said, "Give it 24 hours and then call me back." And sure enough, 24 hours later, the moisture had gotten smaller, and 48 hours later, gone. So the really cool thing about the internal waterproofing systems, they densify the concrete more, which is great for strength and absorption rates and stuff, but they also are always in the concrete sleeping. So at any point in time, if we get a shrinkage crack or even some minor movement cracks, when the water enters in there, it gets in with that waterproofing and actually fills the void. And so it can actually self-repair itself.
So I think the phrase is it's hydroscopic, meaning
right.
it's activated by water. So basically it's lying dormant, kind of like a sleeper cell, and then they get activated whenever the invaders come in, being
Absolutely.
the water.
And so over time they can still protect your project, and they're a huge benefit, and it's a fairly simple process to use, very effective. But if you didn't plan for it or budget for it, it could be extremely expensive. So but it's the first layer that we like to get involved with, and like I said, there's a number of manufacturers. They all have different benefits and additions to them, but definitely work with your manufacturer. And then next to that, we're going to get to topical systems. So talk to me about some topical systems.
I'm going to back up about the integral system. So in my company, when I know that a client is going to be doing an all-tile vessel, even in the ground, I specify integral waterproofers, because I can't deal with most of the internal membrane systems, which we're going to talk about next, can't deal with negative side water pressure.
Right.
And especially for shooting a pool against soil, I can't get a membrane on the backside of that to stop water from migrating through the structure and possibly delaminating my tile, which is a very common source of failure. Guys don't get a very tight shell, and they get a little water migration through the shell. Next thing you know, the membrane is delaminating because of water behind it. So I always tell clients, look, explain to them why. We're going to have a little bit extra cost on our shotcrete or our cast concrete so that we can stop that negative side water. So just something to throw out there for our listeners who might be thinking about doing all-tile vessels, and how do you deal with that negative side water pressure. So next are the membrane systems, and as we kind of touched on, a lot of them can't handle negative side water pressure. That means water that might come in from behind the membrane.
Correct.
So
the amount of vapor pressure that comes from that negative side pressure is pretty dramatic. So even high strength epoxies and unbelievably expensive finishing systems and waterproofing systems, they have almost no ability to manage that kind of pressure from behind, and it will just do exactly that. It starts to bubble it off. So they're important to protect it prior to this piece, but then this piece comes next.
So I actually use a multiple layer effect on the inside of my vessels. Is the very next thing that I use will be a modified cementitious membrane on the inside, and That is usually applied directly to the shotcrete shell or the cast-in-place shell, and then if we're going to be tiling, we'll put our mortar bed on top of that, and then whatever the tile system, elastomeric fracture membrane inside of that. So I've got 3 layers for my integral, my modified cementitious under my mortar bed, and then my waterproof crack control membrane out underneath the tile. But those modified cementitious you can use directly under plaster, I understand.
Yes, many of you can. So the good thing about cementitious is it works through the plaster products too, and so we can actually lay them in. They have 2 advantages. They usually have a reasonable texture to them, so we can actually get mechanical connection to our plasters and key it into that, as well as we naturally can bond because it's cementitious. So they got a lot of polymers in them too, so they got a lot of cure time. So we got to make sure you get your curing times correct. Make sure you don't waterproof day 1 and plaster day 2. And each one's a little bit different, but you absolutely can use that same system and plaster right on top of it. So it's a benefit to some of the membrane systems that you put on. You actually have to come on top of them with something else, usually to plaster, and so that can be difficult if you're trying to just waterline tile, and you'll end up having to waterproof the entire shell, and then you got to come in on top of that with something else if you're only using a membrane.
This episode of the Ask the Masters podcast is being brought to you by Pentair.
So I'm going to back up just a little bit. So before we put that modified cementitious membrane on the inside, we would be doing the mechanical seals around the pipe penetrations. Typically, most contractors are using plastic plaster seals, which are gluing on the pipes and setting back in the wall, and then sealing around that with some type of either hydraulic cement or non-shrink grout. So one of the benefits of the modified cementitious layer on the inside is that because we've got a shotcrete shell that's meeting the hydroscopic cement around the mechanical seal, we have the potential of having a different hydration rate, especially if we're going to plaster a pool.
Sure.
So sometimes we can actually see that shadowing around the pipe penetration. So by lining the whole inside of the pool with the modified cementitious, we now have even hydration across the entire surface.
Right, so to keep you from having some of those weird shadowing effects in some of the plaster around big drains and larger pipe fittings.
Exactly. So there's a key benefit with that. But I've also seen builders come in and just put the modified cementitious around the drain fittings, and they've created even a larger problem because, again, they're getting a differential hydration between the shotcrete and where they've got the membrane.
And by hydration, what you're saying is that where we don't have a membrane, water is getting sucked into the structure more than it would be where we have a membrane, or vice versa. And so that's causing the plaster to change as it cures. It cures in different ways because some of it has more moisture than others. It's critical to keep your shell damp while you're plastering, obviously, but even though you're keeping it surface saturated dry, it's still going to suck some of that moisture from the plaster, and so that's the difference in hydration you're
Correct.
talking about.
And so we see that a lot on projects where, because of the differential materials, where you've got patches around pipes, you've got benches, even densities in the shotcrete change between a bench and steps and the floor. A lot of guys don't realize that a lot of that is just hydration related because the shotcrete might be more porous in other areas, and it's sucking the moisture out of their plaster.
Absolutely. Let's talk to some of the odd type of water issues we have with architecturally integrated structures. What like condensation, for instance? What could we have done that we'd ran into a problem where we think we have a leak, but we actually have a condensation problem?
Well, the problem there is it's the differential temperatures, and so we've got temperatures of the water in the vessel and the air temperature of the room or the adjoining space next to it. That's where you really should have had some type of environmental or mechanical engineer involved dealing with those issues. Sometimes you can put drainage mats or some other type of systems around the outside of the vessel to contain that moisture and redirect it. But if you're against a living space, or that's when really the mechanical contractor needs to get involved and deal with how are we going to drain that water that might be accumulating inside the walls?
Well, drain it and get it, or get enough air movement beyond it so that we don't get that happening. So what we end up happening is we've got a structure full of water that might be 60 degrees, and then we've got another, so that's causing the shell of the structure to be cooler than maybe other parts of the house, and then we have a high humidity situation and warmer weather. So that moisture is actually condensing against the structure that we've built, and now we have moisture moving, either migrating, and if there's enough of it, it can start causing damage, or just naturally being wet too long, we get mold and mildew problems. So,
which is a real big deal, because getting black mold, I did an expert witness case years ago in New York that had black mold in the walls, and it actually gets treated as a hazmat site. The whole house gets sealed, and the guys come in like spacesuits,
yep.
and it's like they're dealing with asbestos, and it's a real bad scene.
And now you're explaining to your neighbors, no, nothing's really wrong. It's no big deal.
Yeah. Really?
Yeah. And we're selling the house next week.
Yeah.
So, yeah, absolutely. So, and that also comes into play, especially when we start putting aquatic structures inside buildings, right? Once we start putting indoor pools and building natatoriums, and even maybe just what seems simple, we're going to put a spa inside somebody's house that's going to be warm all the time and heating all the time. Well, now we've got to deal with a whole other group of environmental issues that aren't as simple as they might seem.
I'm working on another case right now where, again, getting somebody who's done indoor structures and indoor vessels and has a history in doing them and knows all the problems that are related. Everybody tries to, I want to say they want to cheapen out. Everybody wants to try and avoid the expenses of installing a dehumidification system.
Right.
And they all think that, well, I'm going to put fans in, and I'm going to put sliding windows, and I'm going to put skylights, and I'm going to do this, and I'm going to do that. They all think that they're going to reinvent the wheel. And believe me, there have been millions and millions of dollars of lawsuits all around the harebrained ideas trying to avoid the expense of buying a proper dehumidification system.
Well, and even the construction method, we're designing a big project now that's a natatorium for a client, and we've actually enlisted Ruddy, one of our other masters, because that's what he does. Omega Structures builds and does a lot of swimming pools inside structures, and there's all these weird nuances you don't even think of, and simple things of how much air we're moving, especially when we have glass. Where we're building this is actually in New Mexico, so we've got a very cold climate exterior. Well, if we've got 80-degree warm water inside of a building, and we've got 40-degree, 20-degree, 15-degree exterior temperatures, the amount of air movement and air changes and dehumidification that are required, and we can't just dehumidify it. When we talk about condensation, when you've got windows that are in 20-degree weather outside, water will condense on them 24/7 and literally rain in the building and destroy all of the building. And so you actually have to change the entire construction method of the inside of the structure. And when you start locating windows, sometimes you can't locate them where you want to because you can't get enough air to them and keep the air running on them to keep that from happening. And so there's quite a bit of really, long learning techniques over time of how to do that right. And it's certainly not the type of project you want to do a little bit of research online and decide how you're going to build your structure. You need to enlist, even us, we've done a couple of indoor pools already. We still pay for a consultant to come in and look at our designs and even simple stuff. This one actually has a basement that's going to be a wine cellar. He said, we'll have to seal it off completely. And I'm like, well, why? He goes, because the moisture will fall down to that room and you'll never get it out. He goes, you have to
I'm
close
glad
the
you
door.
touched on the moisture migration, because that's something that a lot of people don't think about. So as a swimming pool contractor or the consultants, they're very myopic and just think that their scope of work ends at the walls of the natatorium or the indoor pool. And really, you need to think about the whole building envelope, because as soon as you add that water component, now we're talking about negative and positive air pressures also.
Yep.
And we have to keep the air pressure outside the pool building greater than the air pressure inside the building, so that we're not driving water vapor out into the structure of the house or into the wine cellar in the basement or into the wall cavities.
Right, in through an electrical outlet, or all these. You almost have to hermetically seal these buildings so that does not occur.
It's almost like doing a clean room.
Yeah,
it's
absolutely.
like doing a clean room. So there's literally an entire vapor system. It's like the whole inside of the room is being wrapped with a water barrier. And you're right, the light switches, the outlets, the light fixtures, the can lights, everything. Because we've deconstructed some walls before and found all the electrical wiring corroded. We found the steel studs inside corroded.
Yeah, the moisture, the chemicals, they do highly destructive to most indoor building structures, and so you've got to actually invert the whole construction process. You're actually building the inside as if it's outside now, because we need to be able to manage moving water, rain, and moisture, but also just the migration push. And water migrates unbelievably very well through a lot of different areas, especially once it's in a vapor form in the air. And so you also have to separate parts of the structures, because the swimming pool room itself is a fairly uncomfortable environment. It's too humid, and if you don't keep it cool enough, then it will be very uncomfortable. But if you try to keep it cool, then you have a major problem keeping the pool warm and not having so much evaporation. So there's kind of a little science to that, and then you have to separate building areas and living areas from all those spaces. But it's way more complex than it is just to think, well, we're going to build a little spa in this house, and we're going to put a spa and a hot tub and a cold plunge inside the bathroom area.
And I'm going to put a skylight in to vent it, and we're done.
Correct.
Right.
Yep. So there's a lot more to that. So we've got some experts in our group that can help us navigate that as well. And the cost of solving that problem after the fact is unbelievably expensive. And like you said, it can do a massive amount of damage before you know you have damage.
It's typically a tear down at that point.
Yeah.
You're gutting to the bare studs, and sometimes even the structures of the building has to come down and be reconstructed. You know, something that a lot of people aren't aware of is that oftentimes you can't even bring in a regular HVAC contractor to install those, because it often involves ductwork that they've never even worked with before. They're not using stainless steel or galvanized ductwork. They're actually using PVC and plastic ductwork that's corrosion resistant.
Right. Yeah, and if they're not experienced with that product at all. And the other I've seen on the project we worked on, they also had a system that was running air through a bunch of different rooms, so the return airs were coming from the spa area and the main part of the house, and then we were actually dispersing the air throughout the whole house. So now we had humidity problems everywhere. They were
and chloramines. They're blowing chloramines.
As well as if we got into a condition where that room was full of mold one day, then we'd be spreading the mold around the house. So it's really critical to make sure that's understood, and it's not you're not going to build one of those facilities on the cheap. If you do, it's going to cost you a fortune later. It's that simple. And so it's really, just like many things in this world, it's worth paying up front for a little bit of insurance and understanding than it is to try to solve the problems later.
This episode of the Ask the Masters podcast is being brought to you by Pentair.
What's the toughest architecturally integrated project you've actually had to work on? What's the one that made it? What had some of the most difficult details that you dealt with?
Oh man. I designed one a number of years ago, and it was actually kind of interesting because I designed the project. It was actually going to be a spec home, and a celebrity ended up buying the home, and through kind of roundabout, we're all in this little small society together.
Yep.
The guy who was servicing the pool said, the architecture of this pool kind of looks like Benedetti did it. Let me reach out to him. And he sent me a picture. I said, it kind of looks familiar, but I didn't build it. And he sent me the address, and I looked it up in my computer. I said, we did that project. And it was a rooftop pool with a Lautner edge, and it hung down into a living space. And because the property was a zero lot line, they weren't able to have windows in the bedroom on the top floor. And of course, being a spec house, the builder cut all kinds of corners.
Sure.
It was a steel infrastructure building. None of the steel I-beams had any insulation or anything sprayed on them, which were all supposed to have a polymer, like a truck bed liner sprayed on them all. Well, the condensation in the walls, after a very short period of time, they had the Venetian plaster started delaminating off the walls. They had mold inside. The steel I-beam structures were all rusted. It just, in a very, very short period of time, just because of the condensation from the pool in that cavity around, in the crawl space around the outside. So going in there and kind of deconstructing that and figuring out, what they did, what we have to do to fix it, it ended up being basically a tear out and a rebuild. So that one was kind of interesting because, again, it was in the plans. This is what you need to do. They didn't do it to save a few dollars, and of course, it came back to bite them in the back end. I've got a project I'm doing right now in the Bay Area, which the pool is actually part of the foundation of the home. So we've got common walls, we've got steel I-beam floor structures that are literally welded to plates that we had to embed into the pool wall. So that one's been kind of a challenge because I'm dealing with my subcontractors having interface with the general contractors, subcontractors, and trying to get everybody all on the same page. And so a lot of meetings, a lot of measuring, double checking, triple checking. Kind of sometimes you get things out there in the field that they look good on paper, and you get out there and you go, man, this embed isn't going to quite fit where we've got it. The walls isn't thick enough. We don't have enough coverage. We scramble, go back to the engineer and say, hey, we're going to have to change the thickness of the pool walls here because we just don't have the physical embed. And then he looks at a cross section, of it in Revit and goes, yeah, you're right. There's not enough coverage on the meat on the back of that. So sometimes some things slip through, but then the client comes out and goes, hey, wait a minute, that wall's thicker than I wanted it. Well, sometimes we've got to modify things to
Well, I think you bring up a
things
little
work.
bit of a point as we start getting into the engineering side of this. The team that has to come together, especially if we're going to set, say, the house on top of the pool, we actually start ending up with maybe multiple structural engineers on a project. And so you also need to make sure you're working with engineers that, one, will be willing to work with each other, and two, understand some of the nuances of each person's job. And pool engineering is in general is kind of its own little oddity for most engineers. Most structural engineers and architectural engineers don't have a sense of what pool engineering requirements are. And mostly it's not that they can't do the math, it's they don't understand like what kind of plumbing might be in the wall, and they might show this huge embedded steel embed that's going to be in the way of all kinds of plumbing lines or vice versa. And so we find that too, that we've got to start that early with both engineers. If we're going to we get loading information from the architectural engineer to set on our structure, then we have to design our structure to take those loads, but now we're imparting some other things onto their structure. And it's a back and forth kind of game, but there's a big team that gets put together when you do these structures, and it's not just a simple architect and just a pool guy. You end up with architects, structural engineers, mechanical engineers, another structural engineer, because now the foundation of the pool, or the pool is now the foundation of the house. Those two engineers now have to start talking. And if you're lucky, everybody doesn't get too crazy conservative on you and make it cost you $1 million, but they have to really work well together and start seeing each other. And then ideally, like for us, we work almost always in Revit, try to miss as many of those problems as we can, and try to make the Revit model as accurate as possible. By when we have embed information from the structural, we actually model it and put it in the structure to try to solve us from running into those problems. You're always going to find some of those issues when you get to the site, but as many of those we can minimize, we can start to see that issue, and it really is super helpful on both sides, the builder side and the pool side.
One of the struggles that I find is that oftentimes the homeowners or the project manager is insisting that the home engineer who's designing the structure of the home and the foundations designs the pool. And do you find it sometimes kind of difficult trying to explain to them that pools are kind of a different animal, and there's some limitations on what we can do, which vary a little from cast concrete construction that they're used to, especially bar bends and the density of bars and walls and.
Yeah, I mean, I think one of the things I think that they don't seem to understand either is we actually can run into some tolerances that they're not even willing to, that they don't even deal with. We've got a real long linear water feature we've done at the front of a house, and it's 160 feet long, and it's a perimeter overflow front and a lot in our back. Well, we can't manage any movement, and we've had some movement on that project over time now. So, when you deal with a building that size, if you had a 1/4 inch to 3/8 to even a 1/2 inch of movement across the structure, that would be okay in general times usually, and most of the building materials and structures can manage that. When we're dealing with a perimeter overflow pool structure, our ability to take any tolerance of movement is actually zero, because we're dealing with 16th and 32nd inch tolerances, which in the pool world is really a high level of accuracy. But when you're dealing with these kind of structures, you have to be there, and now you have to plan, how do we plan the structure and engineer it? And most home structural engineers will be looking at deflection and settlement issues much differently than maybe a pool engineer would. So even not just the nuances of the parts inside the pool, they're maybe not thinking of those kind of situations either. So our soils conditions have to be a little bit tighter, or our structural support system has to be better, and we have to be planning for that, and they might not get that either. So it definitely is an education process from the pool guy.
And the longer the edge, the less tolerance there is for movement.
Absolutely.
So you have a smaller structure. If it moves a little bit, it's not quite so critical as something that's 200 feet long.
Yeah. Well, especially if you want to not have to move too much water. Obviously, you can overcome some of that with water movement,
Right.
But when you start getting long edges, then we're talking an excessive amount of water, an excessive amount of power, and not being responsible to the client. So those parts together, but it's a big education piece, and that's why kind of building relationships with architects in town prior to even starting projects is important over time, because once they start understanding what you can provide to their project, you get brought in sooner and sooner, and then you guys start building better projects together, and you're not catching up at the end. And we often get called in too late, and we're catching up, and we have to do trickery to the eye to make it look as though those things are happening. But I think as early as you can get in and as fast as you can work, and hiring the right person. And the other thing I always, one thing I've told even my local pool builders that I've done work for, we design for other pool builders in my market, and sometimes they get these opportunities to work on these pools and they take it, and they should. I don't have a problem with them taking the project, but they also got to recognize when it's outside their wheelhouse and say, I'm going to take the project with builder A because he's my builder. Don't be afraid to go hire Paolo Benedetti to design for you, because he's not going to steal the project from you. Even I, in my own market, we do it all the time. We design a pool somebody else is building, because we have some expertise they don't have. There's nothing wrong with partnering together with a local pool builder and hiring somebody like Red Rock Contractors to come in and help you design something, especially if we have the expertise. We have no reason to want to take that project off your hands. We want to help you build that project because you'll probably bring me more, right?
Exactly.
And that's what same thing as we're a general contractor, so sometimes we get that weird crossover too, where they're like, well, I don't know if I want you working on my job. I'm like, well, I'm not going to steal your client.
Right.
I'm going to help you build this one because I want to build the next 10.
Right.
And so for pool builders out there that maybe don't have the expertise on these items, don't pass the project, don't run from it, but enlist the help of a professional engineer. And if you're afraid of one in your own market, like David Peterson's in California and you can be in Florida.
And reach out.
Reach out.
I do the same thing.
Yeah.
I've got projects in the Midwest right now that we're doing in Oklahoma and in Tennessee. And no, I'm not stealing those. I'm not going to steal their projects, but
right.
It's allowing them to take on bigger contracts that are outside their wheelhouse, yet they know that they've got that resource, somebody they can call up even during construction and say, hey, I ran into this little thing, how do I do this? Or,
right.
Hey, we've got all of our steel and our plumbing in, we review our photos, and I can go through and mark up stuff on an iPad and said, hey, you need to fix this and this and this and this.
Absolutely. I think that they would get, it allows you to take on some projects you couldn't do and really minimize your risk, right? We've paid for either the education or the hard knock side of making mistakes.
Right.
And that can work across the board, whether you're hiring somebody that like a Genesis guy, or even if you've seen somebody else that's built a project that you're trying to do a construction project, like reach out, talk to them. I bet you they're more than willing to tell you the nightmare stories of what they didn't do right. And you can really help yourself do those kind of projects and help the overall team get it done right, whether you bring somebody in or not.
And people I know are sometimes apprehensive about spending that money on a consultant or paying somebody a little bit for that knowledge. But I'll tell you what, on the backside, going in and doing that rework and demolition is going to be much more expensive, and not only in the actual cost to remediate the problem, but you've lost that customer goodwill.
Right.
That customer goes, what the hell did I hire this guy for? He's in here having to demolition things and chase leaks and fix things, and go. You've lost that referral or those 4 or 5 potential projects that could have came out of that.
Absolutely. Hope you enjoyed our podcast on Ask the Masters. I'm Rick Chafey with Red Rock Contractors. And
I'm Paolo Benedetti with Aquatic Technology. Until we see you again.
Thanks for listening to the Ask the Masters podcast, and don't forget to check out our Facebook page each week on Tuesdays for new episodes of the show. I also want to encourage you to stop by the Ask the Masters Facebook page and invite other like-minded individuals to join us there as well. Feel free to jump into the conversations and even post your own questions. We want to create a community which fosters learning and discovery for the betterment of us all. You can also subscribe to the podcast on iTunes, Google Play, and Spotify. Please be sure to subscribe and feel free to share.